UFO is traveling at position 3.6 times 10 to the 11th meters above the Earth at 2,000 meters per second, assuming Earth is at the origin. If the UFO has a mass of 500 kilograms and the Earth has a mass of 6 times 10 to the 30th kilograms, determine the shape of the UFO's path as it approaches the Earth using a time step of 1 day. This is a problem that requires multiple iterations because we are supposed to determine the path that the UFO takes, in addition to the fact that FNet is changing because the strength of the interaction between the Earth and the UFO increases over time. In the line coding for FNet, we see that the denominator contains magnitude of r. We know magnitude of r is the distance between the UFO and the Earth, which becomes smaller over time as the UFO travels towards the Earth. And because our numbers are so big, we turn to a computer program to do the calculations for us. So first thing we do is define our constants, and after we set those, they can be used in later equations that are used in the computer-generated iterations. We define our standard capital G, we define momentum, our starting time, and we want to know the UFO's path in 1 day, so we do a few unit conversions to find that there are 86,400 seconds in a day, so that's our delta T. And in order to visualize the results of GlowScript's iterations, we place objects in space to represent the Earth and the UFO. So I'm representing them as spheres, and because Earth is significantly bigger than the UFO, I made the radius larger, and I also made it blue for a better image. And now we can actually move on to coding for iterations. So we'll be iterating 3,000 times for good measure to ensure that we have enough to visualize the UFO's path. The most important first step in doing an iteration is calculating the net force because it could be different each time. We can assume that the forces on the UFO are constant because we aren't given any forces acting upon the UFO except for gravity. Thus, FNet is essentially just the force of gravity on the UFO by the Earth, and this is our FNet for all iterations. The next big step in each iteration is to update momentum. Then we use our future momentum in the calculation of future position. We want GlowScript to tell us what our position is each iteration, so we code it to print the position is blank plus r. And we're going to do 100 iterations per second to save time. So while the Earth remains stationary, we need to follow the path of the UFO. So we indicate to GlowScript to trace this path visually with make_trail equals true. When we run the program, we see that because the UFO's mass is so much smaller compared to that of the Earth, as we've said before, FNet increases because the magnitude of r, or the distance between the UFO and the Earth, decreases, thereby effectively increasing FNet. And it looks like the alien operating the UFO didn't do a very good job with calculating the path, because the ship bounced right off the surface of the Earth, or what appears to be the bottom of the ocean. And I can't explain this because I don't know what happened, but we see that after the ship leaves the Earth, it appears to have a constant velocity and momentum. And this is ultimately the path that the UFO takes. I hope you enjoyed this little scenario and commentary. Thank you so much for watching.